408 years ago, the telescope was invented. About a year later, a man named Galileo Galilei heard about it and made his own. Then he did something really clever. He looked at the night sky with it. He saw a lot of things, but I'm here today to talk about one discovery in particular. Galileo looked at Jupiter with his telescope and saw 4 little stars all in a line with Jupiter. He called them stars at first, but was intrigued to see that they followed Jupiter in the sky and changed positions in their lineup. Like Jupiter, they were not fixed relative to the stars in the sky. They were not stars. Galileo eventually determined that the Medicean stars, as he called them, were moving around Jupiter, orbiting it. They were moons, or satellites of Jupiter. This was a crucial discovery because it was proof that not everything in the sky was revolving around the Earth. Today, we call these moons the Galilean Moons, after Galileo himself. Galileo named the moons after the Grand Duke of Tuscany and his brothers, but the names we use today were suggested by Simon Marius. Those names are Ganymede, Callisto, Io, and Europa, all lovers of the god Jupiter from Roman mythology. Here's a mnemonic to help you remember them in order from largest to smallest. Godzilla's car is enormous. Smallest of the Galilean moons is little Europa. Europa has a smooth, solid surface, which is actually made of mostly water ice. And underneath the frozen icy crust is a subsurface liquid water ocean. The surface of Europa is covered in lots of double ridges that form as the icy crust breaks, and then the liquid water from underneath rises to fill the cracks and freezes when it reaches the surface. And then there's Io. Europa is covered in ice. Io is covered in volcanoes. Io's hundreds of active volcanoes make it the most geologically active body in the solar system. Volcanic plumes have been imaged on Io, reaching hundreds of kilometers off of its surface, which is constantly being resurfaced by lava flows. And the reason Io is so volcanically active is that while Jupiter pulls it inward toward Jupiter, the other Galilean satellites pull it out away from Jupiter. So Io experiences extreme tides, but not water tides like we have here on Earth. The tidal pull is so strong that the solid rocky surface of Io is pulled in and out as it orbits around Jupiter. Callisto is a fascinating body, covered in more craters than any other surface that we know of in the solar system. Crater counting is a way to determine how much geological activity is going on. In other words, how old a surface is. The surface of the Earth doesn't have very many craters because there are too many natural processes that wipe them away before they can build up. Volcanoes, rain, tectonics, wind, these things are all constantly resurfacing the Earth. Callisto, on the other hand, has probably been geologically dead for its entire existence. And Callisto is the only known body of its size in the solar system that isn't differentiated, meaning it doesn't have a core like the Earth does, or the rest of the terrestrial planets, or the other Galilean moons. It's just the same mixture of rocky and icy material from the crust all the way down, which is really pretty weird. Ganymede, which has its own magnetic field, is the largest moon, not just of Jupiter, but in the entire solar system. In fact, it's bigger than the planet Mercury. It has light and dark terrain. The dark terrain is kind of like the surface of Callisto, old and very cratered, while the light terrain is more like the surface of Europa, younger and very icy. This difference in terrain suggests that Ganymede was once geologically active, but it doesn't seem to be geologically active today. The Galilean moons actually only make up a small number of Jupiter's moons. As of the making of this video, we've discovered 67 moons in the Jovian system, but the Galilean moons are by far the largest. Many of Jupiter's smaller satellites, A, have retrograde orbits, meaning they orbit Jupiter opposite the direction that Jupiter spins, and B, do not orbit Jupiter in the same plane that the Galilean moons do. Most of these smaller satellites are probably asteroids that have been captured by Jupiter's gravity. Thanks for watching! Please like, comment, and subscribe. This video is part of our Jupiter Week series, celebrating the arrival of Juno at Jupiter. If you'd like to see more from this series, click here. And if you'd like to check out more of our videos about all things astronomy, help yourself.